Okay, now we're going to take a look at an equation that has fractions but also has a variable in the denominator. And this one's different from the last example because it is not a proportion. It's not a single fraction equal to a single fraction. Notice that on the left side where we have that plus sign there, so that makes it not a proportion. So we need a different method. And the method that we're going to use is going to be to follow those steps from the notes. Let's say that we want to list any restrictions on the variable, clear the equation of fractions, get all your terms on one side and all your variable terms on the other. So first of all, let's talk about restrictions. So we have this x here by itself. So we'll just list the restriction. X cannot be 0. So of course you can never have 0 in the denominator. Since x is a variable, we have to restrict what its value can be, since variables can theoretically be anything. Alright, next we want to find the LCD in order to clear the equation of fractions. So if we think about 2 and 4, least common multiple of those are going to be 4, but we do have that variable there. So we have to include it because, again, your least common denominator is something that cancels all three. So we need the variable there in order to cancel the variable with itself. It has to be common to all three, because whatever we do to one term, we do to each of them. And so in one shot, we want to be able to cancel all fractions. Alright, so if I multiply each of these fractions by 4x, and remember whenever I say multiply, when it comes to fractions, you're dividing first. So 2 goes into 4x, actually 2 goes into 4 2 times, you're left with the x, so 2 goes into 4x 2x times, and 2x times 1 would just be a 2x. X goes into 4x, well, the x's would cancel, so x would cancel and we would be left with the 4. 4 times 9 is 36. In this case, the 4's would cancel. 4 goes into 4x. 4's would cancel. You'd be left with x. X times 5 is 5x. Now, if any of that did not make sense, it may help you to kind of just do it over on the side. If I would have a 1/2 and a 4x, the 2's, 2 goes into 4 2 times, you'd be left with 2x. You could do that on the side if that makes more sense for you. I just try to take the most efficient route, so that way you guys get in the habit of that, and these problems become more easy and doable and less tedious and aggravating. Alright, so we want to get the variables to one side, and we want to divide both sides by 3, and there you have it.